Welcome back to our Spring Boot tutorial series. Today, we have an exciting topic to cover: creating a GET API that returns a JSON response. This is a key skill for building modern web applications. Let's jump right in and see how it's done. In our previous video, we created a GET API that returned plain text. While plain text is simple, it can't be easily understood or parsed by other systems. Suppose we need to return detailed employee information like name, age, etc. One way to do this is by returning JSON or XML. In this tutorial, we'll focus on returning JSON. Imagine you want to fetch employee details. Instead of plain text, we'll use JSON to structure the data, making it easy for other systems to parse and use. JSON is a widely used format for data exchange, perfect for modern web applications. So, how do we return JSON from a GET API? Let's dive in and see how it's done. We'll create an endpoint that sends back a JSON response with employee details. This is going to be exciting and super useful. First things first, we need to create an employee service and a model class. These will help us organize and manage the employee data we want to return in our JSON response. Let's get started by building these essential parts. Let's start by creating a new package called model. Now, let's create the employee class inside the model package. Now, let's define the details for our employee. We'll include fields like employee ID, employee name, age, joining date, and department. This will give us a comprehensive data model for our employee information. Ready? Let's add these details to our employee class and see it come together. For the department field, let's create an enum that contains values like developer, QA, and HR. Let's create a new package called enums. Now, let's create the department enum inside the enums package. This enum will contain the values developer, QA, and HR. Now, let's define the department field in our employee class using the department enum. We need to define getters and setters for our employee class, but let's be honest, that can be pretty tedious. Fortunately, we have Lombok to save us. Lombok is a fantastic Java library that reduces boilerplate code by automatically generating getters, setters, constructors, and more with just a few simple annotations. This means less manual coding and more time to focus on the fun parts. Ready to make our employee class smarter with Lombok. As you can see, we've already added Lombok to our project. If you followed along with our last video, you'll remember that we included the Lombok dependency when we created the employee service project using the Spring Boot initializer. But don't worry if you missed that step. Just add the Lombok dependency to your pom.xml file as shown on the screen. This little addition will let us use Lombok annotations to automatically generate getters, setters, and more, making our coding life so much easier. Let's make sure everyone is on the same page and ready to use Lombok magic. To automatically generate getter methods, we need to add the @getter annotation just above our employee class. This Lombok annotation will take care of creating all the necessary getter methods for us. Let's add it. To automatically generate setter methods, we need to add the @setter annotation just above our employee class. This Lombok annotation will take care of creating all the necessary setter methods for us. Let's add it. To automatically generate a no-argument constructor and an all-arguments constructor, let's use Lombok annotations. Add at noArgs constructor and at allArgs constructor above our employee class. This will handle creating these constructors for us. Let's add these annotations. Let's also add the @builder annotation just above our employee class. The @builder annotation allows us to create objects using the builder pattern, making our code more flexible and readable. I'll make a separate video to dive deeper into the builder design pattern, so stay tuned for that. Now, let's move on to creating our employee service interface. Watch closely on the screen as I type service.employeeService in IntelliJ. IntelliJ will automatically create a service package and then generate the employee service interface inside that package. This interface will define all the methods we need to manage our employee data. Next, let's define a getEmployees method in our employee service interface. This method will return a list of employees. Now, let's create the employee service impl class within an impl package. This class will provide the implementation for the employee service. Annotate this class with @service to mark it as a service layer component. This tells Spring Boot to create a bean for this class, allowing it to be managed and injected where needed. Next, let's implement the employee service interface in our employee service impl class. Now, let's override the getEmployees method in our employee service impl. Since we haven't covered databases or JPA yet, we'll keep things simple by using a map to store our employee details. In this map, the key will be the employee ID and the value will be the employee object. This approach will let us easily manage our employee data. Let's create a noArgument constructor for our employee service impl class. In this constructor, we'll set up our map and add some sample employee data. This will give us some data to work with as we build and test our API. Create employee 1. Let's create employee 1 using the builder pattern. Start by typing employee.builder. Oh no, not seeing the builder option. If you're facing the same issue, try this. Open IntelliJ Preferences by typing Ctrl+Alt+S on Linux. We might need to install the Lombok plugin. Search for Lombok in the Plugins section of IntelliJ Preferences. Install the first Lombok plugin that appears in the search results. Now that we have the builder option available, let's set up the employee details. Use the builder to set the name, age, joining date, and department. Let's create 2 more employee details in a similar way, with employee ID 2 and 3. Now, let's put all these employee objects into our map. Let's make our getEmployees method return all the employees stored in our map. We'll take each employee from the map, add them to a list, and return that list. Next, let's create the employee controller. Annotate the employee controller class with @RESTcontroller. Also, let's add the @request mapping annotation just above the class. And set the path to employee. This way, all the REST endpoints in this class will have employee as their base URL. Next, we'll create the Get API to retrieve employees. We'll start by adding the @getMapping annotation and setting the produces attribute to media type application_JSON to return a JSON response. Make sure you import org.springframework.http.mediatype in your code. The value of media type application_JSON_value is application/JSON, which tells the client to expect a JSON response. Then, we'll define our getEmployees method. This method will return a response entity holding a list of employee objects. First, let's inject the employee service variable using constructor dependency injection. Call employee service.getEmployees to get all employees. Next, create a new response entity object, passing the list of employees as the body and HTTP status OK as the status code. Now, let's start the application. Now our application is up and running. The getEmployees method we created doesn't have a specific URL defined at the method level, only at the class level. This means its URL will be localhost 8080/employee. Next, let's open Postman to test our new Get API. In Postman, let's add a new HTTP request. Select the HTTP method type as GET. Enter the URL localhost 8080/employee. Next, click on the Headers tab. As you can see, Postman has already added an accept header with a wildcard value asterisk, which means it will accept any type of response. Let's uncheck this header and add a new accept header with the value application/JSON. This tells our API that we expect a JSON response. Click on the Send button. Now, just scroll down to see the response. Oh no, it looks like something's wrong with our service layer code. We're only seeing 2 records, but we added 3. Open Employee Service Impl. It looks like we used Employee ID 2 for both Employee 2 and Employee 3, causing the map to override the record. Let's change the Employee ID for Employee 3 to 3, save the changes, and restart the application. Once the application has restarted, go back to Postman and click on the Send button again. Scroll down a bit to see the response. Great! This time, we received details for all 3 employees. The first employee, Ram, is in the developer department. The second employee, Sham, is in the QA department. And our third employee, Mohan, is in the HR department. Everything matches what we set, which means our API is working perfectly. You might notice that the response starts with square brackets instead of curly brackets. This is because we returned a list of employees, so the response is in the form of a JSON array. JSON arrays are enclosed in square brackets, while JSON objects are enclosed in curly brackets. This format is perfect for returning multiple records. As you can see, our API currently supports responses in JSON format. We've restricted this by defining application/JSON in the produces attribute of our @getMapping. But what happens if we set the accept header in Postman to application/XML? Let's check it out. Change the accept header to application/XML. And click Send to see the response. As you can see, we received an HTTP status code of 406 not acceptable. This means that our API does not support application/XML. Our API is specifically designed to return JSON responses, and that's why it rejected the request for XML. In the logs, you can see that Spring threw an exception indicating that the media type application/XML is not supported. In this case, Spring throws an HTTP media type not acceptable exception. This exception indicates that the requested media type is not supported by our API. You might have noticed that the response body was empty when this happened. Ideally, we should send a proper error response in such cases. We'll cover how to handle these exceptions and send appropriate error messages in a future video in our REST tutorial series. Stay tuned. As you saw, when we made a proper request in Postman, we received a nice JSON response. But wait a minute. We only returned a list of employees from our method. So, who converted the list of employees into JSON and when did this happen? It's quite fascinating, right? Don't worry, we'll dive into all these details in a separate video in this tutorial series. We'll uncover how Spring Boot seamlessly handles this conversion behind the scenes, and we'll also explore how you can write your own custom code for this if needed. Stay tuned for some exciting insights and advanced techniques. Today's video summary. We learned how to create a Get API in Spring Boot that returns JSON responses. We used Lombok to simplify our code with annotations like @getter, @setter, @noargs constructor, and @allargs constructor. We created a service layer and used a map to store our employee data. We tested our API using Postman and discussed handling unsupported media types. You can find the complete code on our GitHub, link attached in the description. Thank you for watching. Don't forget to subscribe and turn on notifications so you don't miss any updates. Stay tuned for more exciting tutorials.